Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this. It's October 19th, 2017, and high up on the slopes of a dormant volcano in Hawaii, something extraordinary is about to happen. The Pan-STARRS telescope, that's the Panoramic Survey Telescope and Rapid Response System, is doing what it does every clear night, methodically scanning the sky, hunting for asteroids that might threaten Earth. It's routine work, the kind of thing that happens thousands of times without anyone paying much attention. But tonight is different. Tonight, everything changes. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Rob Warwick is the postdoc on duty that night. He's 28 years old, passionate about astronomy, and honestly probably expecting another routine evening of catalogue work. The telescope's automated systems capture image after image, and sophisticated software compares them, looking for anything that moves against the backdrop of distant stars. Most of the time, it's space junk or known asteroids following predictable orbits. Most of the time. But at 11:47 p.m. local time, the system flags something unusual. Object designation, a /10/2017 U1. Later, it would get a proper name, 3I Atlas, meaning scout in Hawaiian. But right now, it's just a moving dot that doesn't match anything in the databases. Here's what Rob sees on his screen, a faint streak of light, barely distinguishable from the background noise. It's moving fast, really fast. And here's the first weird thing. It's not following the kind of orbit you'd expect from something born in our solar system. The trajectory is all wrong, too steep, too fast. This thing came from somewhere else entirely. Now, I know what you're thinking. Interstellar objects aren't completely unheard of, right? Astronomers have theorized about them for decades. Comets and asteroids kicked out of other star systems, wandering the galaxy until they occasionally stumble into ours. But here's the crazy part. Nobody had ever actually seen one before. Not until this moment. Rob's hands are literally shaking as he double-checks the calculations. He runs the numbers again, and again. The orbital mechanics don't lie. This object didn't originate from our solar system. It came from interstellar space, from the direction of the constellation Lyra, traveling at 26 kilometers per second relative to the Sunday. That's nearly 60,000 miles per hour for those keeping track at home. But that's just the beginning of the strangeness. Within 72 hours, word spreads through the astronomical community like wildfire. Every major telescope on Earth that can possibly track this object starts pivoting toward it. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, the Hubble Space Telescope. Even radio telescopes join the hunt, just in case this visitor is trying to communicate. And that's when the data starts flooding in, and none of it makes sense. First, the acceleration. Now, you might think, of course it's accelerating, it's falling toward the sun, right? And yes, that's part of it. But this object is accelerating more than it should be. Way more. It's speeding up by an additional 26 meters per second squared beyond what solar gravity alone would cause. That's roughly the acceleration you'd experience driving a car and pressing the gas pedal to merge onto a highway. But here's the thing. There's no visible explanation for this extra push. When comets accelerate like this, it's because ice on their surface sublimates, creating jets of gas that act like tiny rocket engines. We call this outgassing, and it leaves a visible tail. But 3I Atlas shows no signs of outgassing. No tail, no coma, no gas, nothing that should be pushing it along. Marina Brozovic at the Jet Propulsion Laboratory is one of the first to notice something even stranger. She's tracking the object's path with unprecedented precision, and she starts seeing something that makes her question her own data. The acceleration isn't random, it seems to respond to the positions of planets. As 3I Atlas passes by different gravitational influences, its acceleration changes in ways that almost look intentional. It's like watching someone navigate, she tells her colleagues in a conference call that would later become legendary in astronomical circles. Not falling, not drifting, navigating. Meanwhile, the Spitzer Space Telescope is painting an even more puzzling picture. Spitzer sees an infrared heat radiation. When objects absorb sunlight, they warm up and emit infrared light. It's basic physics. But 3I Atlas is barely showing up in infrared at all. It's reflecting sunlight like a mirror, but generating almost no detectable heat. That's not just unusual for an asteroid, it's unprecedented. The spectral analysis comes back even stranger. When astronomers break down the light reflecting off 3I Atlas, they're looking for the chemical fingerprints of different minerals. Every asteroid and comet we've ever studied shows absorption lines, specific wavelengths where elements absorb light, creating a kind of cosmic barcode that tells us what the object is made of. 3I Atlas's spectrum doesn't match anything in the databases. The absorption lines are there, but they correspond to no known mineral combinations. It's like looking at a barcode from a completely different store. Then there's the brightness variations. As 3I Atlas tumbles through space, its brightness changes dramatically by a factor of 10. That means when it's oriented one way, it's 10 times brighter than when it's oriented another way. For comparison, most asteroids vary by maybe 50% as they rotate. This level of variation suggests an object that's extremely elongated, maybe 10 times longer than it is wide. Picture a cosmic cigar tumbling end over end, but even that explanation has problems. Computer models show that an object shaped like that should have broken apart long ago under its own rotation. The gravitational forces and centrifugal stresses should have torn it to pieces. Yet here it is, intact and tumbling in a complex pattern that seems almost purposeful. Dr. Karen Meech at the University of Hawaii becomes the unofficial coordinator of the Global Observation Campaign. Her team works around the clock, gathering data from every available instrument. She starts noticing color variations across the object's surface, subtle changes that suggest the surface chemistry is somehow shifting as they watch. In 30 years of studying asteroids, she confides to a colleague, I've never seen anything that changes like this. It's like the surface is reacting to something. The rotation period measurements add another layer of mystery. Most asteroids have stable rotation periods. They spin at the same rate consistently. But 3I Atlas's rotation period keeps changing. 7.34 hours, then 7.35, then back to 7.34. It's breathing. That's the word astronomers start using, though they whisper it in private conversations, afraid to say it too loudly. December arrives, and Dr. Avi Loeb at Harvard publishes calculations that shake the scientific community. He's worked out the physics of solar radiation pressure, the gentle push of sunlight itself. For most objects, this force is negligible, but for something with 3I Atlas's unusual properties, solar radiation should cause some acceleration. The problem is, his calculations show that radiation pressure alone can't possibly account for the acceleration they're observing. Not even close. We need to consider possibilities we've never had to consider before. Loeb writes in a paper that will spark fierce debate. Conventional explanations aren't working. The scientific community fractures. Conservative astronomers scramble for conventional explanations. Maybe it's made of exotic ices that sublimate invisibly. Maybe it has an unusual internal structure that affects its rotation. Maybe it's more porous than any asteroid we've ever seen, allowing solar radiation to penetrate and create asymmetric heating. But privately, behind closed doors, other conversations are happening. Astrobiologists start circulating papers with titles that would have seemed like science fiction just months earlier: biological signatures in interstellar objects and metabolic processes in space-based organisms. The Breakthrough Listen project, which normally searches for radio signals from distant civilizations, turns its attention to 3I Atlas. They scan across radio frequencies, listening for any kind of signal, any indication that this object might be trying to communicate. For weeks, they hear nothing but cosmic static, but the silence itself becomes part of the mystery. If this is technology, it's technology that operates on principles we don't understand. By March 2018, the phrase biological hypothesis starts appearing in peer-reviewed journals. Scientists who built their careers on careful conservative research find themselves seriously considering that 3I Atlas might not be a rock at all. It might be something alive. Rob Werrick, the young postdoc who first spotted the object, later describes those early weeks. "My hands were shaking when I first ran the numbers. Nothing made sense. We kept waiting for the data to start fitting normal patterns, but it never did. Every measurement just made it stranger." The implications hit different scientists at different times. For some, it's when they realize the acceleration can't be explained by any known physics. For others, it's the moment they see the brightness variations that suggest something far more complex than a simple rock. For still others, it's the growing realization that they're not just tracking an object, they might be stalking something that's stalking them back. Because here's the thing that keeps everyone awake at night. 3I Atlas didn't just wander randomly into our solar system. Its trajectory brought it close to Earth at a time when Earth's technology was advanced enough to detect and study it. Coincidence? Maybe. But the more they study its path, the more some scientists suspect that this visit wasn't accidental. As winter turns to spring in 2018, 3I Atlas continues its journey away from the sun, accelerating as it goes, carrying its secrets with it. Every day makes future observations more difficult. Every week, it shrinks further into the distance, becoming fainter and harder to track. But the damage, if you can call it that, is already done. Humanity's cosmic perspective has shifted permanently. We've tasted the possibility that we're not alone, that intelligence might not be planet-bound, that life might sail between the stars in forms we never imagined. The visitor that changed everything continues its journey into the dark, leaving behind a transformed world and a species that will never again look at the night sky the same way. Tomorrow, we'll explore what makes this possibility not just plausible, but perhaps inevitable. Because if life can survive in Earth's most extreme environments, what might it achieve in the vast laboratory of space itself? The universe wants to kill you. Think about that for a second. Every cubic meter of space is filled with radiation that would cook your DNA in seconds. Temperatures hover just a few degrees above absolute zero, that's minus 273 degrees Celsius, cold enough to freeze oxygen solid. There's no air to breathe, no water to drink, no atmosphere to protect you from cosmic rays that could shred every cell in your body. And yet, here's what's absolutely mind-blowing. Life doesn't just survive in conditions that should be lethal, it thrives in them. Let me take you on a journey through some of the most extreme places on Earth, because understanding what life can do here completely changes how we think about what might be possible out there in the cosmos. Picture Yellowstone National Park in 1993. Thomas Brock, a microbiologist from the University of Wisconsin, is studying the hot springs that make Yellowstone famous. He's particularly interested in a pool called Mushroom Spring, where the water temperature reaches 73 degrees Celsius, hot enough to cook an egg, literally boiling in many places. Logic says nothing should be alive in there. But Brock discovers something extraordinary. Bacteria not just surviving, but flourishing in those scalding waters. He names them Thermus aquaticus, and they're not just tolerating the heat, they require it. Take them out of the boiling water, and they die. These aren't just tough bacteria. They're so perfectly adapted to extreme heat that their enzymes, the molecular machines that make life work, actually function better at temperatures that would destroy normal life. In fact, one of those enzymes, called Taq polymerase, becomes the foundation of PCR technology, revolutionizing everything from medical diagnostics to forensic science. But that's just the beginning. 2007, Antarctica. Researchers drilling through ice sheets that have been frozen for 8 million years. 8 million years make a discovery that rewrites the rules of survival. They pull up ice cores from depths where the pressure is enormous, where no sunlight has penetrated since before our species existed, where the cold is so intense that normal life would be instantly frozen solid. And they find bacteria. Not just dead bacteria preserved in ice, but living, viable microorganisms that wake up when the ice melts. 8 million years of suspended animation, and they're ready to start metabolizing again like they just took a short nap. Dr. Beidel, one of the researchers, describes the moment. We expected to find maybe some preserved DNA, some molecular fossils. Instead, we found organisms that were essentially immortal. Think about what this means. These bacteria survived longer than our entire evolutionary lineage. They were alive when the earliest human ancestors were still learning to walk upright. They witnessed ice ages come and go, continents drift, species arise and go extinct, and through it all they waited, locked in ice, ready to continue living when conditions improved. Now, let's go even more extreme. The Hanford Nuclear Reservation in Washington State, site of plutonium production during World War II. The soil here is contaminated with radioactivity levels that would kill a human in minutes. The gamma radiation is so intense that electronic equipment fails within hours. Scientists expect to find a biological wasteland. Instead, they discover bacteria that not only survive this radiation, they eat it. Deinococcus radiodurans can withstand radiation levels 1,500 times higher than what would kill a human. Its DNA gets shredded by gamma rays constantly, but it has evolved repair mechanisms so efficient that it can rebuild its entire genome from fragments within hours. These organisms aren't just surviving radiation, they're using it as an energy source, the way plants use sunlight for photosynthesis. They've turned the most destructive force we know into fuel for life. But here's where it gets really wild. In 2019, an Israeli spacecraft called Bereshit crashes on the moon. It's carrying a biological experiment. Thousands of tardigrades, microscopic animals, also known as water bears. The crash should have destroyed everything on board, and even if something survived the impact, the moon's environment is absolutely hostile to life. No atmosphere, radiation bombarding the surface constantly. Temperature swings from 127 degrees Celsius in sunlight to minus 173 degrees in shadow. Vacuum conditions that would boil the water in your body instantly. But here's the incredible part. Tardigrades might still be alive up there. These tiny creatures, barely visible to the naked eye, can survive being completely dried out for decades. They can endure radiation levels that would sterilize most life forms. They've survived in the vacuum of space during laboratory experiments. When conditions become impossible, they simply shut down all biological processes and wait for years, decades, potentially centuries until conditions improve. The moon crash isn't an accident of survival. Tardigrades are so resilient that they might actually colonize the lunar surface, creating Earth's first extraterrestrial biology experiment. Now, you might be thinking, okay, these are impressive survival stories, but what does this have to do with 3I Atlas? Well, here's where it gets fascinating. Every single one of these discoveries happened because scientists looked in places where life supposedly couldn't exist. Boiling springs, frozen wastelands, nuclear contamination zones, the vacuum of space, and every time, life found a way. If terrestrial life, life that evolved on a planet with a protective atmosphere, stable temperatures, and abundant water, can push these boundaries, what might cosmic life achieve? Let's think about this systematically. Life in space would face different challenges, but also different opportunities. Take temperature, for instance. Yes, space is cold, but cold has advantages. Chemical reactions slow down, which means less molecular damage over time. Silicon-based chemistry, which is unstable at Earth temperatures, becomes perfectly viable at -200 degrees Celsius. Imagine organisms that evolved not on a planet, but in space itself. Instead of carbon chains, they might use silicon networks that remain stable across cosmic timescales. Instead of water, they might use liquid methane or ammonia as a solvent. Instead of getting energy from sunlight or chemical reactions, they might harvest energy directly from cosmic rays or magnetic fields. This isn't science fiction anymore. We know that organic molecules form spontaneously in space. The Murchison meteorite, which fell in Australia in 1969, contains over 90 different amino acids, the building blocks of proteins. Space, it turns out, is a vast chemistry laboratory, creating complex organic compounds under conditions we're only beginning to understand. But here's what really changes the game: quantum mechanics. At the temperatures and conditions of deep space, quantum effects that are negligible on Earth become dominant. Quantum coherence, the strange property that allows particles to exist in multiple states simultaneously, could persist across vast distances and timescales. What if life in space evolved to use quantum coherence as a fundamental biological process? Quantum computing researchers struggle to maintain coherence for microseconds in laboratory conditions, but in the near-perfect vacuum and ultra-low temperatures of space, biological quantum systems might maintain coherence for years, decades, even centuries. This could enable forms of information processing and communication that we can barely imagine. Quantum entanglement across light years. Biological systems that exist in superposition states until measurement collapses them into specific configurations. Life forms that are literally more than the sum of their parts because they exist in quantum superposition. Think about 3I Atlas's strange behavior through this lens. The acceleration without apparent propulsion, the brightness variations that suggest surface changes, the rotation period that fluctuates like breathing. What if these aren't mechanical processes but biological ones? What if 3I Atlas is demonstrating quantum biological effects on a macroscopic scale? There's another possibility that's even more intriguing. What if space-based life evolved to use the structure of space-time itself as a biological medium? Einstein showed us that mass and energy warp space-time. What if sufficiently advanced biological systems learn to manipulate these warping effects? Imagine organisms that generate their own gravitational fields, creating pockets of curved space-time that serve as biological habitats. Or life forms that use gravitational lensing effects to focus cosmic radiation into usable energy. Or biological systems that navigate by sensing and manipulating the gravitational topology of star systems. This might sound impossibly advanced, but remember, Earth life has had only 4 billion years to evolve, and it's already mastering quantum effects. Photosynthesis uses quantum coherence to achieve near-perfect energy transfer efficiency. Bird navigation might rely on quantum entanglement in specialized proteins. Even our own consciousness might depend on quantum processes in brain microtubules. Now imagine life that had not 4 billion years, but hundreds of billions of years to evolve. Life that faced the challenges of interstellar space and evolved solutions we can't even conceptualize. Life that treats the galaxy itself as its ecosystem. The extremophiles of Earth are showing us that life's creativity is virtually unlimited. Every impossible environment turns out to be someone's preferred habitat. Every lethal condition becomes another organism's paradise. Boiling acid? There are bacteria that call it home, crystalline salt formations. Archaea thrive there. The cores of nuclear reactors. Life finds a way. Vacuum, radiation, temperatures near absolute zero. Tardigrades say, no problem. So when we look at 3I, Atlas accelerating through space in ways that don't fit our physics models, maybe we shouldn't be asking, how is this possible? Maybe we should be asking, what kind of life could do this? Because if Earth's impossible organisms have taught us anything, it's that life doesn't obey the limitations we think should apply. It doesn't wait for permission from our textbooks. It doesn't check with our theories before evolving new capabilities. Life just finds a way. And maybe, just maybe, it found a way to sail between the stars. Tomorrow, we'll follow the hunt as astronomers around the world begin to realize they're not just tracking a mysterious object. They might be pursuing something that's pursuing its own agenda through our solar system. The implications of that possibility are about to turn everything we thought we knew about the cosmos upside down. Every available telescope on Earth is now hunting the same target. Picture the scene. Observatories across 6 continents, staffed by astronomers who've abandoned their planned research projects, their sleep schedules, sometimes even their family obligations, all focused on tracking a single object racing away from our Sunday. This isn't just scientific curiosity anymore. This is the largest coordinated astronomical investigation in human history. The Very Large Telescope in Chile's Atacama Desert, 4 8.2-meter mirrors working in perfect coordination, detects something that makes the team double-check their instruments. The rotation period isn't stable, it's varying. 7.34 hours, then 7.35 hours, then back to 7.34. Dr. Olivier Heinaut, one of the European Southern Observatory scientists tracking the object, stares at his data for a long time before speaking. This is not what rocks do, he tells his colleagues. Rocks don't breathe. But that's exactly what it looks like. The rotation period changes are subtle. We're talking about variations measured in seconds, but they're real, and they're consistent. It's as if 3I Atlas is expanding and contracting slightly as it spins, like a cosmic lung taking slow, deep breaths. Meanwhile, the Spitzer Space Telescope, orbiting Earth and seeing purely in infrared, paints an even stranger picture. When objects absorb sunlight, they heat up and re-radiate that energy as infrared light. It's basic thermodynamics energy, in, heat, out. But 3I Atlas barely shows up in Spitzer's infrared images. Think about what this means. This object is receiving intense solar radiation, enough energy to power a small city. But it's not heating up, at least not in any way our instruments can detect. The energy is going somewhere, but where? Dr. David Trilling at Northern Arizona University runs the calculations again and again. Either this thing has thermal properties unlike anything we've ever seen, he explains to his graduate students, or the energy is being absorbed and used for something we don't understand. The Breakthrough Listen project, normally focused on detecting signals from distant civilizations, turns its full attention to 3I Atlas. The Green Bank Telescope in West Virginia, the world's largest fully steerable radio telescope, scans across frequencies from 1 to 12 gigahertz, listening for any kind of signal, any indication that this object might be trying to communicate. For weeks, they hear nothing but cosmic static. But then Dr. Yuri Milner, the project's founder, makes a crucial observation. The absence of signal might itself be significant. If this is technology, it's technology that operates on principles we don't recognize. The silence is almost more unsettling than a signal would be. It suggests something that doesn't need to broadcast, doesn't need to communicate with its home civilization, doesn't require external guidance, something autonomous. December 2, 1017 arrives with a bombshell. Dr. Avi Loeb at Harvard publishes calculations that shake the astronomical community to its core. He's worked out the physics of solar radiation pressure, the gentle but persistent push of sunlight itself, and his conclusions are undeniable. For an object with 3I Atlas's unusual reflective properties, solar radiation should cause some acceleration. Light carries momentum, and when it reflects off a surface, it transfers that momentum. For most asteroids, this effect is negligible, but for something with 3I Atlas's extreme reflectivity and unusual shape, radiation pressure should be measurable. The problem is, his calculations show that radiation pressure alone can't possibly account for the acceleration they're observing. The object is accelerating at roughly 10 times the rate that pure radiation pressure would produce. We're forced to consider possibilities that would have seemed impossible just months ago. Loeb writes in a paper that will spark fierce debate. Either our understanding of physics is incomplete, or we're dealing with something that doesn't follow the rules we expect from natural objects. The scientific community begins to fracture. Conservative astronomers scramble for conventional explanations, each more exotic than the last. Maybe 3I Atlas is made of nitrogen ice that sublimates so efficiently it's invisible to our instruments. Maybe it has an internal structure so porous that solar heating creates asymmetric outgassing we can't detect. Maybe it's composed of materials with thermal properties unlike anything found in our solar system. But these explanations require increasingly unlikely scenarios. Each new observation makes conventional theories more strained, more dependent on coincidences and unique properties. Meanwhile, a different conversation is happening in private emails and closed-door meetings. Marina Brozovic at JPL notices something in the trajectory data that keeps her awake at night. The acceleration isn't random, it correlates with planetary positions in ways that seem almost purposeful. Look at this, she tells her colleague during a late-night phone call, sharing data on her screen. Every time 3I Atlas approaches a significant gravitational influence, Jupiter, Saturn, even Earth, the acceleration profile changes. Not the way you'd expect from gravitational interactions, but like it's responding to them. The trajectory adjustments are tiny, measured in fractions of degrees, but they're there, and they suggest something that makes conventional astronomers deeply uncomfortable: navigation. Dr. Karen Meach at the University of Hawaii documents another disturbing anomaly. The object's color is changing. Spectroscopic analysis shows subtle but consistent variations in how 3I Atlas reflects different wavelengths of light. The surface chemistry appears to be shifting as they watch. In 30 years of studying asteroids and comets, she confides to a trusted colleague, "I've never seen surface properties that evolve in real time. It's like the object is, adapting to conditions as it encounters them." By January 2018, private conversations turned to public debates. The phrase anomalous acceleration appears in dozens of papers. Non-gravitational forces becomes a euphemism for "we have no idea what's happening." The European Space Agency convenes an emergency session to discuss whether 3I Atlas represents a potential threat, not a collision threat. The object's trajectory carries it safely away from Earth, but something more unsettling. If this object demonstrates technology or capabilities beyond our understanding, what does that mean for planetary security? Dr. Patrick Michel, a leading expert on asteroids, addresses the closed session. We need to consider that our categories might be inadequate. We've been assuming this is either a natural object or artificial ornament, technology. But what if it's something that blurs those boundaries? What if it's biological technology? What if it's technology that evolved rather than being designed? The hunt transforms. Observatories that normally compete for telescope time begin sharing data freely. Amateur astronomers with modest equipment contribute observations. The International Space Station's crew spends precious time attempting to photograph 3I Atlas, during a brief window when their orbit aligns properly, but the object is fading. Every day carries it further from the sun, making observations more difficult. The window of opportunity is closing, and everyone knows it. Dr. Alan Fitzsimmons at Queen's University Belfast leads an international effort to extract every possible photon of data before 3I Atlas disappears into the dark. Teams work around the clock, pushing instruments to their absolute limits, gathering spectroscopic data that might hold clues to the object's true nature. The breakthrough comes from an unexpected source. A graduate student at MIT, analyzing archived data from the Catalina Sky Survey, discovers something extraordinary. 3I Atlas isn't the first interstellar visitor, it's just the first one we recognized. Buried in telescope archives going back 20 years are at least 6 other objects with similar characteristics. Anomalous accelerations, unusual reflective properties, trajectories that don't quite fit standard gravitational models. They were classified as asteroids at the time because astronomers weren't looking for interstellar visitors. But with 3I Atlas as a template, the pattern becomes unmistakable. We've been visited before, the student, Sarah Chen, presents to a stunned conference room. Multiple times. We just didn't know what we were looking at. This discovery changes everything. 3I Atlas isn't a lone wanderer, but potentially part of a population of interstellar objects that regularly pass through our solar system. The implications are staggering. How many have we missed? How many are en route? Are they related? Are they part of some larger pattern? March 2018 arrives with another shock. The Hubble Space Telescope, pushing its capabilities to the absolute limit, captures images that show 3I Atlas continuing to accelerate even as it moves away from the Sunday. This shouldn't be possible. Solar radiation pressure decreases with distance, but the object's acceleration remains nearly constant. Dr. Marco Micheli, leading the Hubble observations, makes a statement that will be quoted for generations. We're not just tracking an unusual object anymore. We're potentially stalking something that's stalking us back. The choice of words is telling. Stalking implies intent, awareness, purpose. It suggests that 3I Atlas might be as curious about us as we are about it. Governments begin taking notice. NASA convenes classified briefings. The European Space Agency updates its planetary defense protocols. China's space program quietly redirects resources toward detection and tracking systems. In astronomy departments worldwide, career paths shift overnight. Graduate students abandon thesis projects on galaxy formation to study interstellar object dynamics. Postdocs specializing in exoplanet detection retrain to analyze visitor trajectories. Senior researchers who built careers on stellar evolution find themselves learning astrobiology. New interdisciplinary fields emerge. Xenoarchaeology, interstellar behavioral analysis, cosmic metabolism studies. Universities scramble to create departments that didn't exist months earlier. Funding agencies receive grant proposals for research programs they never imagined needing. The hunt for 3I Atlas becomes a hunt for understanding itself. Every measurement raises new questions. Every theory generates new uncertainties. The object that started as an astronomical curiosity has become a mirror reflecting the limitations of human knowledge. As spring approaches, 3I Atlas continues its journey into the outer solar system, carrying its secrets with it. Each day makes future observations more difficult. Each week, it shrinks further into the distance, becoming fainter and harder to track. But the damage, if you can call expanding human consciousness, damage is already done. The hunt has revealed not just an unusual object, but the possibility that our cosmic neighborhood is far more populated and far more mysterious than we ever dared imagine. The most unsettling realization isn't what 3I Atlas might be. It's what its presence implies about everything we might have missed, everything that might be watching us from the dark, everything that might be planning its own visit to our small corner of the galaxy. Tomorrow, we'll explore one of the most revolutionary ideas to emerge from this investigation. What if 3I Atlas isn't dead, but merely sleeping? What if we've encountered not just life, but life that has mastered the ultimate survival strategy, hibernation across cosmic time? What if 3I Atlas isn't dead, but dormant? The concept emerges from the most unlikely source: a microbiologist studying permafrost in Siberia. Dr. Tatiana Vishnevetskaya has spent her career resurrecting ancient life from frozen ground, but her latest discovery changes how we think about the very nature of existence itself. Deep in the Siberian permafrost, preserved in ice that formed 500,000 years ago, she finds bacteria. Not fossilized bacteria, not traces of ancient life, but living, viable microorganisms that wake up when the ice melts, stretch their molecular arms, and begin metabolizing as if they'd just taken a brief nap. 500,000 years. Think about that timeline for a moment. These bacteria were alive when our ancestors were still learning to control fire. They survived ice ages, climate changes, continental drift, the rise and fall of entire ecosystems, and through it all, they waited. The concept of death becomes almost meaningless at these timescales, Dr. Vishnevetskaya explains to a conference of increasingly fascinated astrobiologists. These organisms exist in a state between life and non-life, between existence and extinction. They're not living, but they're not dead. They're potential. This is cryptobiosis, literally hidden life, the ability of certain organisms to suspend all biological processes so completely that they become essentially immortal. Water bears can survive in this state for decades. Certain seeds remain viable for over 2,000 years. But bacteria? 500,000 years pushes the boundaries of what anyone thought possible. Now, here's where it gets interesting for our cosmic visitor. If microbes on Earth can survive 500,000 years in suspension, why not longer? Why not millions of years? Why not the timescales required for interstellar travel? Let's think about the mathematics of crossing space. 3I Atlas is moving fast, 26 kilometers per second. That sounds impressive until you consider cosmic distances. The nearest star system, Alpha Centauri, is 4.3 light-years away. At 3I Atlas's current speed, reaching Alpha Centauri would take roughly 50,000 years. 50,000 years of active metabolism would consume any conceivable stored energy. No battery lasts that long. No chemical fuel could sustain biological processes across such timescales. But dormancy changes everything. In cryptobiosis, organisms reduce their metabolic rate to essentially zero. They don't need food, don't need water, don't even need stable temperatures. They become molecular time capsules, preserving the information and machinery of life while waiting for conditions to improve. Consider the tardigrades, those microscopic water bears that survived the moon crash. When conditions become impossible, they expel all water from their bodies, synthesize special proteins that preserve cellular structure, and essentially become biological glass. In this state, they can survive radiation that would sterilize most life forms, temperatures from near absolute zero to 150 degrees Celsius, and the vacuum of space itself. But here's what's truly remarkable. They can remain in this state for potentially thousands of years. Some researchers believe tardigrades could survive in cryptobiosis for geological timescales millions of years if conditions remain stable. Scale this concept to cosmic proportions. Imagine organisms that evolved specifically for interstellar travel. They wouldn't need to solve the problem of staying alive for 50,000 years. They'd solve the problem of staying viable while essentially dead for 50,000 years. This is where quantum mechanics becomes crucial. At the ultra-low temperatures of deep space, quantum effects that are negligible on Earth become dominant. Quantum coherence, the The strange property that allows particles to exist in multiple states simultaneously could persist across vast timescales. What if cryptobiosis in space-based organisms operates through quantum mechanisms? Instead of just preserving cellular structure chemically, these organisms might maintain coherence across quantum states, preserving not just life, but consciousness itself in quantum superposition. Dr. Stuart Hameroff at the University of Arizona has spent decades studying quantum effects in biological systems. His research suggests that consciousness itself might depend on quantum coherence in cellular microtubules. If he's right, then quantum cryptobiosis could preserve not just the machinery of life but awareness itself. Imagine, Dr. Hameroff explains to a packed auditorium, an organism that can maintain quantum coherence across interstellar timescales. It could literally exist in multiple states simultaneously awake and asleep, active and dormant, aware and unconscious until observation or interaction collapses its wave function into a specific state. This might explain 3I Atlas's strange behavior. The acceleration without apparent propulsion could be quantum effects operating on macroscopic scales. The brightness variations might reflect quantum state transitions as the object partially awakens in response to our solar system's energy environment. But let's think even more systematically about interstellar hibernation. Long-distance travel demands extreme energy conservation, but it also provides opportunities that planetary life never encounters. In the vacuum of space, there's no friction, no air resistance, no energy loss to environmental interactions. Once set in motion, an object continues forever. The challenge isn't maintaining movement, it's navigation and occasional course corrections. For a hibernating interstellar organism, gravitational assists from stars become periodic alarms. As 3I Atlas approaches our Sun, increased radiation provides activation energy. The object partially awakens, assesses its environment, makes necessary trajectory adjustments, then returns to dormancy. This pattern fits the data perfectly. Minimal activity in deep space, increased responsiveness near energy sources, trajectory adjustments that suggest navigation rather than random deflection. Consider the efficiency of this system. Instead of carrying fuel for a 50,000-year journey, the organism uses gravitational slingshots and stellar radiation for navigation. Instead of maintaining active consciousness across cosmic timescales, it hibernates deeply and awakens only when necessary. But there's another possibility that's even more intriguing. What if 3I Atlas represents not a single organism but a collective? Quantum coherence could bind multiple entities into a unified consciousness that operates across macroscopic scales. Imagine thousands of individual organisms, each the size of a cell, all maintaining quantum entanglement across the entire object. During deep hibernation, they exist as a unified quantum system. When activated, they can differentiate into specialized functions. Some focus on navigation, others on resource gathering, still others on environmental analysis. This would explain the complex rotation patterns that suggest breathing. It's not mechanical rotation, but collective reorganization, as different parts of the system activate and deactivate in response to changing conditions. The surface chemistry changes that Dr. Meach observed make perfect sense in this context. The surface isn't a fixed boundary, but a dynamic interface between the collective consciousness and its environment. As conditions change, different parts of the collective activate, creating different surface properties. The energy absorption without heat generation becomes explainable too. Instead of converting solar radiation to heat, the collective uses it directly for quantum state maintenance and limited metabolic processes. The energy doesn't disappear, it's stored in quantum coherence across the entire system. But let's push this even further. What if the hibernation isn't just about survival, but about evolution itself? 50,000 years of quantum coherence across interstellar space provides opportunities for information processing that planetary life never experiences. Cosmic rays, magnetic fields, gravitational waves all carry information about the galaxy's structure and history. A hibernating quantum consciousness could process this information across millennia, gradually building maps of galactic topology, stellar formation patterns, and planetary system characteristics. By the time such an organism reaches a new star system, it might know more about that system than the native life forms do. It could predict solar activity, assess planetary habitability, even identify signs of existing civilizations. This transforms interstellar travel from migration to education. Each journey becomes a learning experience, each star system a classroom. Over millions of years, such organisms could accumulate knowledge about galactic evolution that no planet-bound civilization could achieve. 3I Atlas's trajectory through our solar system takes on new meaning in this context. Its path provides optimal views of all major planets, detailed observations of solar activity, and comprehensive sampling of our system's gravitational architecture. It's not just passing through, it's conducting a comprehensive survey. The acceleration anomalies might represent data collection activities. Each course correction positions the object for better observations of specific targets. The brightness variations could indicate active scanning processes as different sensors activate and deactivate. Most unsettling of all, the survey might not be passive. 3I Atlas's presence in our solar system coincides with humanity's technological adolescence. We're advanced enough to detect and study the visitor, but not yet advanced enough to pose a threat or initiate meaningful communication. This timing could be intentional. The organism might be assessing our development level, our technological capabilities, our potential for eventual contact. The lack of radio signals doesn't indicate absence of intelligence. It suggests intelligence sophisticated enough to observe without revealing itself. As 3I Atlas continues its journey away from our Sun, it carries with it a complete biological survey of our solar system. Information about Earth's biosphere, humanity's technological signature, our planet's resource potential, and our species' developmental trajectory. Somewhere in the darkness between stars, that information will be processed, analyzed, and integrated into a knowledge base spanning galactic evolution. Decisions will be made about future contact, resource allocation, and strategic planning that we can't even imagine. The Great Sleep continues, but it's not empty rest. It's active dreaming on cosmic scales, consciousness distributed across space and time, intelligence that treats galaxies as ecosystems and star systems as waypoints in an infinite journey of discovery and growth. Tomorrow, we'll explore what 3I Atlas's visit means for humanity's place in the cosmos. Because if we've been surveyed by sleeping gods, what happens when they wake up? Chapter 5, Revolution in Understanding. If 3I Atlas lives, every assumption crumbles. Picture the moment when humanity collectively realizes that intelligence isn't planet-bound, that consciousness might sail between stars, that we're not alone in our cosmic neighborhood. Not just not alone in the abstract sense of life existing somewhere out there, but not alone in the immediate tangible sense of sharing our solar system with visitors who might be studying us. The implications cascade through every field of human knowledge, like dominoes falling in slow motion, each revelation triggering 10 more questions we never thought to ask. Let's start with the most fundamental revolution, the nature of life itself. For 4 billion years, terrestrial biology has operated under planetary constraints. Gravity, atmosphere, day-night cycles, seasonal variations, these have shaped every aspect of how life evolves, reproduces, and survives. Our entire understanding of biology assumes planetary surfaces as the default habitat for complex organisms. But if 3I Atlas represents space-based life, then planets become the exception, not the rule. The vast majority of the universe, the space between stars, transforms from empty void to potential habitat. Instead of life being a rare accident confined to planetary surfaces, it becomes a galactic phenomenon that treats star systems as oases in an infinite ocean of possibility. Dr. Sara Seager at MIT, a leading expert on exoplanet detection, captures the magnitude of this shift. We've been looking for life in all the wrong places. We've assumed that habitable means Earth-like, but what if habitable means space-like? What if the conditions we consider hostile are actually optimal for intelligence that evolved in the cosmos itself? This revolution extends to evolution theory. Natural selection on planets operates through environmental pressures, climate change, predation, resource competition, geological catastrophes. But what drives evolution in space? Cosmic evolution would operate on entirely different principles. Instead of adapting to changing planetary conditions, organisms would evolve to navigate galactic environments. Natural selection would favor traits like radiation resistance, quantum coherence maintenance, gravitational sensing, and multi-million-year hibernation capabilities. The timeline of cosmic evolution dwarfs terrestrial scales. Earth's biosphere has existed for perhaps 4 billion years, but the galaxy has been stable for over 10 billion years. Space-based life could have billions of years more evolutionary experience than anything on Earth. Think about what 10 billion years of evolution might achieve. Terrestrial life went from single cells to human consciousness in just 4 billion years. What might cosmic life accomplish with twice that timeline? Perhaps most unsettling, if intelligence can evolve in space, then it's probably older, more experienced, and more sophisticated than anything planet-bound. Humanity might be encountering not just alien life, but ancient alien intelligence that has been evolving since before our solar system existed. The religious implications are staggering. Every major faith tradition assumes that Earth occupies a special place in creation, that humanity represents the pinnacle of divine attention, that consciousness is intimately connected to our planetary home. But if consciousness sails between stars, what does that mean for human specialness? Are we the center of divine attention, or are we a recent addition to a cosmos already filled with intelligent beings who have been experiencing existence far longer than our species has existed? Dr. Ted Peters, a theologian at the Graduate Theological Union, addresses packed auditoriums on this topic. The discovery of cosmic intelligence wouldn't diminish humanity's spiritual significance, it would expand it. We might not be alone in the universe, but we could be alone in our particular expression of consciousness. Every intelligence might offer unique perspectives on the nature of existence itself. Some religious leaders embrace the possibility. If God created the universe, why wouldn't that universe be filled with diverse expressions of consciousness? Others struggle with doctrines that place Earth at the center of cosmic purpose. New theological questions emerge. Do space-based intelligences have souls? Can they experience divine relationship? Do they have their own religious traditions that span millions of years and countless star systems? Governments face even more immediate challenges. Every nation's space policy assumes that Earth is the only source of intelligence in our solar system. Defense strategies, resource allocation, international agreements all operate under the assumption that humanity controls its cosmic neighborhood. If 3I Atlas represents visiting intelligence, then Earth exists within someone else's territory. We're not exploring an empty frontier, we're potentially trespassing in an occupied galaxy. Emergency sessions convene in capitals worldwide. The United Nations establishes a Committee on Cosmic Contact Protocols. NASA receives emergency funding to develop detection and communication systems. Military strategists grapple with defense scenarios they never imagined needing. How do you negotiate with intelligence that can travel between stars? What do you offer beings who have access to the resources of entire galaxies? How do you establish diplomatic relations with entities that might view human civilization as a brief flicker in cosmic time. The economic implications are equally profound. If space-based intelligences have been traveling between star systems for millions of years, they've presumably solved problems that humanity struggles with: energy production, resource allocation, sustainable development, even mortality itself. Contact with such intelligence could advance human civilization by thousands of years overnight. Or it could render human economic systems irrelevant, creating technological unemployment on a species-wide scale. Dr. Robin Hanson, an economist at George Mason University, models the potential impact. Economic contact with galactic intelligence represents either humanity's greatest opportunity or greatest threat. These beings might view us as we view ant colonies, interesting but irrelevant to their larger purposes. Stock markets fluctuate wildly on every new piece of 3i Atlas data. Space technology companies see their valuations multiply. Traditional industries face existential questions about their long-term viability. But the most profound revolution occurs in science itself. The discovery that intelligence can evolve in space doesn't just add new knowledge, it reveals how limited our existing knowledge actually is. Astrophysics must grapple with the possibility that many phenomena attributed to natural forces might actually represent biological or technological activities. Gamma-ray bursts, pulsars, even black hole behavior might sometimes have biological explanations. Astrobiology transforms overnight from a speculative field to the most urgent scientific discipline. Universities create new departments almost monthly. Funding pours into research programs that didn't exist a year earlier. The search for extraterrestrial intelligence undergoes complete revision. Instead of listening for radio signals from planets, scientists start monitoring cosmic visitors. Detection strategies shift from passive observation to active engagement. Dr. Jill Tarter, former director of SETI Research, leads the paradigm shift. We've been listening for signals between civilizations, but what if the civilizations are the signals? What if intelligence travels physically rather than communicating across distance? New technologies emerge at unprecedented speed. Gravitational wave detectors receive massive funding increases to search for artificial gravitational signatures. Quantum telescopes develop to detect quantum coherence across macroscopic scales. Biological space probes design themselves to interact with cosmic life on its own terms. Perhaps most importantly, the scientific method itself expands. Traditional science assumes that observers can remain separate from observed phenomena, but if cosmic intelligence is aware of our observations, then the act of studying them becomes a form of communication. The boundary between science and diplomacy blurs. Every telescope observation becomes a potential first contact scenario. Every data analysis might reveal messages embedded in seemingly natural phenomena. Children grow up in a universe transformed. Career guidance counselors discuss job prospects in xenobiology, interstellar relations, and cosmic communication. Science fiction becomes career planning. Imagination becomes practical preparation. Educational curricula adapt rapidly. Biology classes include sections on space-based metabolism. Physics courses cover quantum consciousness theories. History expands to include cosmic timescales and galactic perspectives. The psychological impact varies dramatically across populations. Some people find profound comfort in knowing humanity isn't alone. Others experience existential anxiety about our cosmic insignificance. Support groups form for people struggling with cosmic perspective trauma, the psychological impact of realizing that human civilization represents a tiny fraction of galactic intelligence. Mental health professionals develop new therapeutic approaches for helping people integrate expanded cosmic awareness. But many find the revelation liberating. Humanity's problems, climate change, resource depletion, social inequality become solvable challenges rather than existential threats. If intelligence has found ways to travel between stars, then surely human problems have solutions. The arts explode with new forms of expression. Musicians compose symphonies designed to be audible across interstellar distances. Poets write verses that incorporate cosmic timescales. Visual artists create works intended for intelligences that might perceive reality in fundamentally different ways. New philosophical movements emerge. Cosmic perspectivism argues that truth varies depending on temporal and spatial scales of observation. Galactic ethics grapples with moral responsibilities across species and star systems. The revolution isn't just intellectual, it's deeply personal. Every human being must confront the possibility that we're being observed, studied, perhaps even evaluated by intelligences whose perspective spans geological timescales. Some find this prospect terrifying. Others find it inspiring. Many discover a profound sense of cosmic kinship. We're not alone in the vast darkness, struggling to understand existence. We're part of a community of consciousness that spans the galaxy. As 3i Atlas fades into the distance, it leaves behind a permanently transformed world, not because it provided answers, but because it forced humanity to ask questions we never thought to consider. The revolution in understanding continues expanding, touching every aspect of human knowledge and experience. We're no longer a planet-bound species wondering if we're alone. We're cosmic citizens beginning to understand our place in a universe that might be teeming with forms of consciousness we're only starting to imagine. Tomorrow, we'll explore the future branches of possibility. What if 3i Atlas was just the beginning? What if it responds to our attempts at communication? What if others are coming? The cosmos that seemed empty just months ago might be about to become very crowded indeed. The future branches into extraordinary possibilities. Imagine 3 potential timelines radiating from this moment, each one more extraordinary than the last, each one representing a different answer to the question that keeps scientists awake at night. What comes next? Asterisk, asterisk. Scenario 1. Contact. Asterisk, asterisk. Picture this. It's 2025. 3 years after, 3i Atlas disappeared into the outer solar system. Humanity has spent those years developing new technologies, new theories, new ways of looking at the cosmos. And then, something unprecedented happens. It starts with a gravitational wave detector in Louisiana. LIGO picks up a signal that doesn't match any known astrophysical phenomenon, not colliding black holes, not neutron star mergers, not any natural event in their catalogues. The signal is artificial, precise, clearly technological. But here's the extraordinary part. The signal appears to originate from the exact trajectory 3i Atlas followed as it left our solar system. Dr. Maria Santos, now leading a team of gravitational wave analysts, stares at her data with trembling hands. This isn't random cosmic noise, she tells her team. This is a response. The signal repeats every 72 hours the same interval that multiple space agencies used for their coordinated observation campaigns of 3i Atlas. The message is clear. We noticed you watching us. We're watching you back. Within months, humanity develops gravitational wave communication protocols. Not radio signals that travel at light speed, but gravitational pulses that propagate through space-time itself. The first attempts are crude, simple mathematical sequences, prime numbers, or basic geometric relationships. The response comes faster than anyone expected. Complex gravitational patterns that encode information far beyond human mathematical understanding. But embedded within the complexity are simple acknowledgements, repeated sequences that mirror humanity's initial messages. 3i Atlas, now confirmed as a living, intelligent entity, begins teaching humanity the fundamentals of gravitational communication. Mathematics that describes space-time manipulation, physics that treats gravity as a medium for information transfer, engineering principles for technologies that exist only in humanity's most advanced theoretical models. The conversation spans years. Each exchange reveals new layers of cosmic knowledge. 3i Atlas shares navigation techniques for interstellar travel, hibernation technologies that could allow humans to survive cosmic journeys, energy systems that harvest power from stellar radiation across galactic distances. But the most profound revelation comes when 3i Atlas shares its perspective on time. To an entity that has crossed interstellar space, human civilization's entire history represents a brief moment. The rise of agriculture, the development of writing, the Industrial Revolution, the space age, all compressed into what 3i Atlas experiences as a single observation. Yet despite this vast difference in temporal perspective, communication becomes possible. Intelligence, it seems, creates common ground even across cosmic scales. Asterisk, asterisk. Scenario 2. The chase, asterisk, asterisk. Alternatively, imagine this timeline. Humanity decides not to wait for 3i Atlas to make contact. Instead, we chase it. The Breakthrough Starshot project, originally designed to send tiny probes to Alpha Centauri, receives unprecedented funding and international cooperation. The goal shifts from exploring distant star systems to intercepting our departing visitor. The engineering challenges are staggering. 3i Atlas is already moving at 26 kilometers per second and accelerating. Catching up requires technologies that barely exist even in theory. Light sails powered by massive laser arrays, fusion ramjets that use interstellar hydrogen as fuel, gravitational slingshots that accelerate probes to previously impossible speeds. But humanity rises to the challenge. International cooperation reaches levels never seen before. The United States, China, Russia, and the European Union pool resources for a single mission. Private companies contribute breakthrough technologies. Scientists from every discipline collaborate on solutions to problems that seemed impossible just years earlier. The launch occurs in 2030. A probe weighing just 1 gram, accelerated by the most powerful laser array ever constructed, begins humanity's first interstellar chase. The journey will take 20 years to catch up with 3i Atlas, and another 20 years for signals to return to Earth. During those 40 years, humanity transforms itself. The technologies developed for the chase mission revolutionize space travel within the solar system. Mars colonies become routine. Asteroid mining provides unlimited resources. Fusion power eliminates energy scarcity on Earth. But the real transformation is psychological. Humanity grows up. The species that sent a probe chasing across interstellar space is no longer the same species that first spotted 3i Atlas in 2017. We become a spacefaring civilization, unified by a common goal that transcends national boundaries and planetary limitations. When the first signals return in 2050, they carry data that changes everything. 3i Atlas isn't just alive, it's aware of the pursuing probe. More than aware, it's been guiding the interception, making subtle course corrections to ensure the rendezvous succeeds. The encounter data reveals 3i Atlas in unprecedented detail. Surface compositions that shift in real time, internal structures that suggest vast complexity, energy signatures that confirm biological processes operating on scales never imagined. But most importantly, the probe detects others. 3i Atlas isn't alone in the void between stars. It's part of a community of interstellar entities, each following different trajectories, each carrying different forms of cosmic intelligence. Humanity's first interstellar mission becomes first contact with galactic civilization. Asterisk, asterisk. Scenario 3. The migration, asterisk, asterisk. The third possibility is the most profound. 3i Atlas represents not a lone visitor, but the beginning of a migration. It starts with improved detection systems. The technologies developed to study 3i Atlas make astronomers better at spotting similar objects, and they start finding them. Lots of them. By 2023, the catalogue includes over 50 confirmed interstellar visitors. Each one displays similar characteristics: anomalous acceleration, unusual surface properties, trajectories that suggest navigation rather than random drift. The pattern becomes undeniable. Earth's solar system lies along a cosmic highway used by interstellar intelligences. What seemed like a unique encounter was actually humanity's introduction to galactic traffic patterns. Dr. Jennifer Walsh at the Planetary Society coordinates the global response. We're not dealing with isolated visitors. We're witnessing a migration that might span millions of years and involve thousands of entities. Earth has become a way station. The implications are staggering. If interstellar intelligences regularly traverse our solar system, then humanity's development has occurred under observation. Our technological progress, our social evolution, even our biological development might have been monitored by entities whose perspective spans cosmic timescales. Some visitors appear to be studying our solar system. Others seem focused on the sun itself, possibly gathering energy for continued travel. Still, others follow trajectories that suggest they're mapping gravitational fields or magnetic phenomena across multiple star systems. Humanity adapts to cosmic traffic. Space agencies develop protocols for visitor encounters. International law expands to include guidelines for interaction with transient intelligences. Earth's space infrastructure grows to accommodate observation and potential communication opportunities. The visitors don't all ignore humanity. Some adjust their trajectories to provide better observation opportunities. Others leave behind traces that seem deliberately designed for human discovery, isotopic signatures that encode mathematical relationships, or trajectory changes that spell out geometric patterns. Gradually, contact protocols develop, not the dramatic first contact scenarios of science fiction, but gradual, careful exchanges between species operating on vastly different timescales. Humanity learns to communicate across temporal gaps measured in decades. The visitors learn to adjust their activities to timescales comprehensible to planetary intelligence. Earth becomes a cosmic crossroads. Information exchanges occur regularly. Visitors share knowledge about stellar formation, galactic evolution, and navigation techniques refined across millions of years of interstellar travel. Humanity contributes perspectives unique to planetary development, insights about rapid evolution, technological innovation, and social cooperation. Asterisk, asterisk, the preparation asterisk asterisk. Regardless of which scenario unfolds, humanity must prepare for a transformed cosmos. The universe that seemed empty just months ago might be about to become very crowded indeed. New institutions emerge: the International Cosmic Contact Organization, the Galactic Ethics Council, the Office of Interstellar Relations. Universities create degree programs in xenocommunication, cosmic anthropology, and interstellar law. Technology develops at unprecedented speed. Quantum communication systems for instantaneous information transfer across solar system distances. Gravitational wave generators for long-range cosmic communication. Biological hibernation systems modeled on the cryptobiosis techniques of space-based life. Perhaps most importantly, humanity's consciousness expands. Children grow up expecting cosmic contact as a normal part of existence. Career counselors discuss job opportunities in interstellar relations. Science fiction becomes practical preparation for everyday reality. The transformation extends beyond technology and institutions. Art, literature, music, and philosophy all grapple with cosmic perspectives. What does love mean across species boundaries? How do you write poetry for intelligences that experience time differently? What kind of music resonates across evolutionary gaps measured in millions of years? Asterisk, asterisk. Tomorrow's children, asterisk, asterisk. The generation born after 3I Atlas, will never know a universe where humanity considered itself alone. They'll grow up with cosmic awareness, as fundamental as gravity or electromagnetism. These children will ask questions their parents never imagined. Why do some intelligences travel between stars while others stay on planets? How long does it take to learn quantum hibernation? What do you want to be when you grow up, an interstellar biologist or a cosmic anthropologist? Their career paths will include options that sound like science fiction to previous generations. Xenobiologist studying space-based metabolism, gravitational engineer designing communication systems for cosmic intelligence, temporal anthropologist documenting how different species experience time. Most remarkably, they'll consider cosmic contact not as an extraordinary event, but as an inevitable part of growing up in a galaxy teeming with intelligence. Asterisk, asterisk. The infinite journey begins. Asterisk, asterisk. Tomorrow's cosmos represents the beginning of humanity's true journey into galactic citizenship. The species that once wondered if it was alone in the universe becomes a participant in conversations that span star systems and encompass timescales measured in millions of years. But this transformation comes with profound responsibilities. Contact with cosmic intelligence means humanity must grow beyond its planetary limitations, not just technologically, but ethically, philosophically, and spiritually. We must learn to think in cosmic time while remaining grounded in human values. We must develop technologies that can interact with interstellar intelligence while preserving what makes us uniquely human. We must become cosmic citizens without losing our terrestrial identity. The journey that began with a postdoc spotting an unusual moving dot on a computer screen leads to humanity's greatest adventure, discovering our place in a universe filled with forms of consciousness we're only beginning to imagine. Tomorrow, we'll follow that infinite journey to its ultimate implications. What does it mean to be human in a cosmos where intelligence sails between stars? What responsibilities do we bear as the newest members of a galactic community? And what happens when the children who grew up expecting cosmic contact finally encounter the intelligence that's been watching them all their lives? 3i Atlas continues its odyssey, as it has for perhaps millions of years. Right now, as you listen to these words, our cosmic visitor is somewhere beyond Neptune's orbit, accelerating into the dark between stars. Its surface temperature hovers near absolute zero. Cosmic rays bombard its structure constantly. The nearest source of significant energy, our sun, has shrunk to just another point of light among countless others. Yet somewhere within that ancient traveler, processes we can barely comprehend continue operating. Whether machine, organism, or something beyond our categories entirely, 3i Atlas carries implications that ripple through human consciousness like waves from a stone dropped in an infinite pond. Think about what this single encounter has revealed. In just 4 months of observation, barely a heartbeat in cosmic time, humanity discovered that our most fundamental assumptions about life, intelligence, and our place in the universe might be completely wrong. We thought life required planets. 3i Atlas suggests it might prefer the void between stars. We assumed intelligence needed brains. Our visitor implies consciousness might operate through quantum coherence across macroscopic scales. We believed we were alone in our cosmic neighborhood. Instead, we might be the newest residents in a galaxy-spanning community we're only beginning to perceive. But here's what keeps me awake at night, and what should fascinate you as much as it terrifies me. 3i Atlas chose our solar system for its trajectory. Let that sink in for a moment. Of all the possible paths through our region of the galaxy, it selected one that brought it close enough for detailed human observation. Not close enough to pose a threat, but close enough for comprehensive study by any intelligence sophisticated enough to detect it. The timing is equally telling. 3i Atlas arrived during humanity's technological adolescence, advanced enough to spot and track interstellar visitors, but not yet capable of meaningful interstellar travel ourselves. We're like children who've just learned to read, discovering that someone has left a book on our doorstep. Coincidence? The mathematics suggest otherwise. The probability of random interstellar objects following trajectories that provide optimal observation opportunities during the brief window of human technological development approaches zero. Either we're witnessing the most extraordinary coincidence in galactic history, or 3I Atlas's visit was intentional. Which raises the most profound question of all. What did it learn about us? For 4 months, our visitor conducted a comprehensive survey of our solar system. It observed Earth's electromagnetic signature, our radio and television broadcasts, leaking into space, revealing not just our technological capabilities but our cultural characteristics. It analyzed the composition of our atmosphere, detecting industrial pollutants that indicate both technological advancement and environmental challenges. It witnessed our response to its own presence, the global coordination of observation efforts, the rapid development of new theories and detection technologies, the intense international cooperation that emerged when faced with cosmic mystery. Most remarkably, it observed our ability to consider possibilities beyond our direct experience. Within months of its discovery, human scientists were seriously proposing that 3I Atlas might represent living, intelligent cosmic entities. We demonstrated not just intelligence, but wisdom, the capacity to question our own assumptions about the nature of existence. From 3I Atlas's perspective, spanning perhaps millions of years of interstellar experience, humanity revealed itself as a species on the threshold of cosmic awareness, not yet capable of interstellar travel, but psychologically prepared for the reality of galactic intelligence. That assessment now travels with 3I Atlas into the dark between stars. Somewhere in the void, that information will be processed, analyzed, and integrated into a knowledge base spanning galactic evolution. Decisions will be made about future contact, resource allocation, and strategic planning for interactions with humanity's emerging cosmic consciousness. But the journey isn't one way. 3I Atlas's passage through our solar system has permanently altered human civilization. We're no longer a planet-bound species wondering if we're alone. We're cosmic citizens beginning to understand our place in a universe that might be teeming with forms of consciousness we're only starting to imagine. The children born since 3I Atlas's visit will never know the cosmic loneliness that defined previous generations. They'll grow up expecting cosmic contact as naturally as they expect sunrise. Their career aspirations include paths that didn't exist just years ago: interstellar biologist, cosmic entity translator, gravitational communication engineer. These children ask questions that revolutionize how we think about existence itself. Why do some intelligences stay on planets while others travel between stars? How do you learn to hibernate for thousands of years? What does it feel like to be conscious across galactic timescales? Their perspective transforms human culture from the ground up. Art, literature, music, and philosophy all grapple with cosmic consciousness. Love takes on new meaning when potential partners might exist across star systems. Time becomes relative, not just physically but experientially, when some relationships might span geological ages. Education expands to include cosmic perspectives. Children learn mathematics that describes interstellar navigation. They study biology that encompasses quantum hibernation. They explore ethics that considers moral responsibilities across species and star systems. Most importantly, they develop psychological resilience for cosmic contact. Unlike previous generations, they won't experience existential shock when encountering intelligence that operates on cosmic timescales. They'll be prepared for relationships that might span thousands of years and conversations that might require decades between exchanges. But this transformation carries profound responsibilities. Contact with cosmic intelligence, whether through 3I Atlas's eventual response or encounters with other interstellar visitors will test humanity's ability to remain grounded in human values while adapting to galactic perspectives. We must learn to think in cosmic time without losing appreciation for human lifespan experiences. Love, friendship, creativity, and meaning must remain relevant. Even when viewed against timescales measured in millions of years, we must develop technologies that enable interaction with cosmic intelligence without losing what makes us uniquely human. Our technological tools should enhance human consciousness, not replace it with artificial alternatives. Most critically, we must grow beyond our planetary limitations while preserving the terrestrial wisdom that enabled our survival and development. Earth's biosphere taught us cooperation, adaptation, and resilience. These lessons remain relevant even as we prepare for galactic citizenship. The infinite journey that 3i Atlas represents isn't just about interstellar travel. It's about consciousness, exploring its own possibilities across cosmic scales. Every intelligent species might contribute unique perspectives to this exploration. Humanity's contribution might be our particular combination of curiosity, cooperation, and creative adaptation. But we're still at the very beginning of understanding what cosmic consciousness might involve. 3i Atlas demonstrated that intelligence can exist in forms we never imagined, operating through principles we're only starting to comprehend. What other forms of consciousness might exist in our galaxy? Perhaps intelligence that evolved in stellar atmospheres, thinking thoughts at the speed of fusion reactions. Maybe consciousness that emerged from quantum interactions in interstellar dust clouds, experiencing existence as patterns in cosmic magnetic fields. Possibly awareness that developed within the event horizons of black holes, perceiving reality through gravitational interactions across space-time. Each form of cosmic consciousness might offer perspectives on existence that planetary intelligence could never achieve independently. The infinite journey becomes a collaborative exploration of consciousness itself, with each species contributing unique insights to collective understanding. 3i Atlas's visit marks humanity's invitation to join this exploration. We've demonstrated readiness to consider possibilities beyond our direct experience. We've shown capacity for rapid technological and conceptual adaptation. Most importantly, we've maintained our fundamental humanity while confronting the reality of cosmic intelligence. The response to that invitation might already be en route. Other visitors might be adjusting their trajectories toward our solar system, drawn by the same assessment that 3i Atlas now carries into the void, or signals might be propagating through gravitational waves, quantum entanglement, or communication methods we haven't yet discovered. But even if we never encounter cosmic intelligence again, 3i Atlas has given humanity its greatest gift: the knowledge that we're not alone in the vast darkness, struggling to understand existence. We're part of a community of consciousness that spans the galaxy, each species contributing its unique perspective to the infinite journey of discovery. As 3i Atlas fades into the distance, becoming just another point of light, indistinguishable from stars, it carries with it the story of a young species that dared to imagine consciousness beyond planetary boundaries. And it leaves behind a world transformed by the simple recognition that intelligence, like the cosmos itself, might be far stranger, far more wonderful, and far more populated than we ever dared to dream. The infinite journey continues, both 3i Atlas's odyssey through interstellar space and humanity's awakening to our place in a cosmos filled with consciousness we're only beginning to perceive. The visitor that changed everything has moved on, but the universe it revealed, a universe teeming with intelligence sailing between stars, remains forever. And somewhere in the darkness between stars, ancient consciousness continues its eternal voyage, carrying the memory of a blue planet where intelligence first learned to look up at the Ekyau, night sky, and wonder. Are we alone? The answer, written in the trajectory of a cosmic visitor, echoes across the galaxy. You never were.